Okay, so I'm going to continue from the previous example. Remember, we calculated the two x coordinate of the turning point, which was this and that. Then I said you are taking this, you substitute on the original equation. Make sure that when you substitute this on the original equation, you are getting this answer in set form. This will be the answer, and then in decimal this will be negative 3,08. So it means now we can say one of the turning point is actually 2,15. Where does the 2,15 comes from? When you do this in decimal, it's actually 2,15, and the y coordinate will be this one. So here I actually use the reason why I did not use the decimal here is because I wanted my solution to be exact. So I didn't want to round off the answer that I'm supposed to substitute on the original equation. So that's why I did not round off here. But then at the end, while I have my turning points, I will say this is my TP1 and then this is my TP2. So even this one of the turning point, when we solve f of prime x is equals to 0, we got this. So when you substitute this on the original curve, you are getting this answer, which you could say is 3,08. So the 3 minus 2 square root 3 over 3 in decimal is actually negative 0,15, and then the corresponding y value, it will be the 3,08. So the next question, which is question number 7 on your discussion question number 7D, they say determine the coordinate of the point of inflation. So under my notes, I did mention that when you want point of inflation, you will let your second prime x is equals to 0. So what is our second prime x? I'm just gonna rewrite my f of prime x here. F of prime x, remember it was 3x squared minus 6x minus 1. So my second prime, I'm differentiating the first prime to get the second prime. So this will be 6x minus 6. So like I said, point of inflation, you let second prime of x is equal to 0. So here's my second prime x. I will take it 6x minus 6. I let this is equal to 0. Then when I solve for x here, I will get x as 1. So they said they want what? The coordinate of the point of inflation. So when you want the x coordinate of point of inflation, when you solve this, in fact, what will this give you? This will give you the x coordinate of point of inflation. Point of inflection. So I explained that when you have the x coordinate and then you want the y coordinate, what are you gonna do? You'll have to take that x coordinate and then you substitute it on the original curve, which our original curve is x cubed minus 3x squared minus x plus 3. So this will be 1 minus 3 minus 1 plus 3. This will be 0. Therefore, point of inflation is 1 and 0. Let me just check if I did the right thing. It's 1 minus 3 minus 1 plus 3, and then let's cancel with that, let's cancel with that. Then we have 0. It's 1 and 0. And the last question, it says sketch the graph of f of x on the answer sheet provided, showing all the turning points. So I'm not gonna draw it to scale. So if I have my Cartesian plane and my x, so I know that my turning points, let me just check on the previous. My turning points are x is equals to, in fact, when you do your x turning point, you let f of x is equals to 0, and then since we do have this factorized, I could say this is x minus 3 and then x plus 1 and then x minus 1. All of this is equal to 0. Then it allows me to say x is equals to 3, x is equals to 1, or x is equals to minus 1. So I got all my x turning point. So if I sketch them here, I will have the 1 here, I will have the -1 here, and I will have the 3, let's say here. And how will the shape of this graph look like? Since our a was a 3, I think, no, a 1, our a was a +1, so we're going to have an increasing function with this shape. So now I have my roots, which are my my x coordinate, x-intercept, I mean, sorry, x-intercept. This is where it will turn, and then this is the shape. And let's look at my turning points. I have one turning point which is 2,15 and then -3,08. If I say this is my 1, 2, 3, and then my other turning point is -0,15 and then 3,08. If I have 1, 2, 3, that will be -3, -2, -1. So how will I sketch this? I know that it's gonna turn here. I mean it's gonna cut here, here, and here. So let me try to sketch my turning points. My turning point is 2,15 and then -3,08. So 2, that will be 1, 2. So 2,15, I could say it could be somewhere here. 2,15 and then -3,08. -3,08. If this is 3, -3,08 could be maybe somewhere there. So that is where I'll have one of the turning points. And then the second turning point, I have -0,15. -0,15 as x. This is -1. So -0,15. That will be close to 0. In fact, it's not even halfway. It's close to 0 somewhere here. And then 3,08. 3,08 can be somewhere here. If this is 3, 3,08 can be somewhere there. So I have my turning points. I know the shape, so I can just join the dots. So this will look something like this. So that will be my graph. Remember, I'm not drawing to scale. Make sure that it curves. And then my y-intercept here. My y-intercept is always the last value that doesn't have x in it, which is 3 here, which is 3 there. And then let's check at the point of inflation. Where is point of inflation? It's the 1 and 0, which is, yes, it's here. So this is point of inflation. In this case, we have point of inflection as is the same as one of the x-intercept, but that's not always the case. So just make sure that you understand that that's not always the case. It's just that in this specific question, we are getting that the point of inflection is the same as one of the x-intercept. So last question, they say determine the equation of the tangent to the curve of f of x where x is equals to 2. Remember, we did equation of the tangent. If we know where the tangent is happening at x is equals to 2, we will take the f of prime 2, which will be our gradient, f of prime 2, that will be 3, 2 squared minus 6, 6, 2 minus 1. 3 times 4 minus 12 minus 1. That will be 12 minus 12 minus 1. That will be -1. Remember, what is this -1? This is our m at x is equals to 2. So we know that at x is equals to 2, our m is in fact 2. So what do we need to calculate? Now we need to calculate the corresponding y value at x is equals to 2. So now if I do my f of 2, I will get 2 minus 3, 2 plus 1, 2 minus 1. I'm using the factorized form, but you can also use the original function. But this is also the original, it's just that it's factorized, and then it's easier to work from this one if I'm not using the calculator, unlike working with the original. So 2 minus 3 is minus 1, and then this will be 3, and then this will be 1. Then I get that is actually negative 3. So where the tangent is happening in terms of a coordinate is actually 2 and minus 3. Then I can go to my equation y minus y1 is equals to m x minus x1. Y minus my y1 is what? Negative 3 is equals to x, my m is negative 1, x minus 2. And then if you solve this, you will end up with y is equals to minus x, and then if I take that one, it will be positive 2, and then positive 3. I take it the other side is going to be negative 3, then I will get negative 1. So this will be the equation of the tangent at x is equals to 2. And let me just show you geometrically how it will look like. Remember, the 2 is here, the 2 is here, and the gradient will look something like this. Even though I didn't draw this to scale, but you can see that actually the 2 should correspond to the 3, so that way the gradient will be, and we can see that that is actually a negative gradient, and also here it shows that actually our gradient is negative.